Yesterday we have started our second unit of artificial intelligence and we have talked about the knowledge representation in AI. We had started another topic is the first order logic or the predicate logic under the knowledge representation, in which we have discussed that it extends the propositional logic by allowing the use of quantifiers and the predicates. We have discussed what are the quantifiers, we have discussed what are the predicates, and what are the components of a first order logic, what comes under the first order logic or the predicate logic. We have discussed this. So what we have discussed yesterday, we have discussed about the predicate logic. What we have discussed yesterday, that we have discussed that it extends the propositional logic by allowing the use of a quantifiers and predicates. It enables the complex statements representation and the objects about their objects and the relationship between the objects also. We have discussed the few components of a predicate logic. What we have discussed about the components of a predicate logic. So what comes under the predicate logic? We have discussed about the quantifiers, right? We have discussed about the universal quantifier. We have discussed about the variables also. Variables also, we have discussed about the logical connectivities between this. What do you understand by the predicates? We have discussed that the predicates describe the properties or the relation between our objects or the variables. Or what we have discussed, that it becomes the propositions when values are assigned to their variables. When we are talking about the predicates, we are talking about they are a generalization of a propositional variables, or we can say that they are the Boolean functions that can be true or false. We have discussed about the quantifiers yesterday. What comes under the quantifiers? We specify the scope of a variable in a logical expression with the help of an and or, right? It specifies the extent to which a predicate is true over a range of elements. Or the two main types of quantifiers we have studied yesterday is the universal and the existential. And we have seen the symbols of both. Then we have discussed that the variable is the another component that comes under the predicate logic when we use in a knowledge representation in an artificial intelligence. And the variable can be any object, or variable can represent an object in a particular domain here. It can be substituted with a particular values also to obtain a proposition. Then we have discussed about the various logical connectivities in the predicate logic that can be such as like and or, right? Or predicate logic is also known as a first order logic. We have discussed these things which use in the various mathematics or the computer science or the linguistics, right? So we have discussed these components, the key components of a predicate logic. What are the components? Comes under the predicate logic. Constants. Constants are the symbols that represent a specific object in a domain, right? Like we have taken an example also. We have discussed about the variables. Variables are the symbol that can represent any object in a domain. We have discussed about a predicate. Predicate represent the properties of object or a relationship between them. And the functions also, functions map the objects to the other objects. Quantifiers we have discussed. And we have discussed the logical connectivities in a form of and or not and implies. Then the equality is another component. Now what comes under the syntax of a first order logic? This we need to know. And what is the semantics of a first order logic? Or what do you understand by the meaning of a first order logic or the predicate statements? So what comes under the syntax of a FOL, which defines the rules for constructing a well form formulas. For what we are using it? We are using it to form a well form formula, to construct our formulas. So first syntax, we are talking about the atomic formulas, or we can define the two types of we can construct the two types of formulas here, the atomic formulas or the complex formulas, right? So what comes under the atomic formulas we have discussed? We discussed that it's a simplest formula which can be predicates applied to terms. Example, here we are taking the variables and we are taking the normal formula form. Then the complex formulas are the combining of a various atomic formulas with the number of a quantifiers and the logical connectivities. As you can see in this example, we are using the universal quantifier and the various predicates and using the implied symbol or the or symbol and the and symbol here. So or symbol here. So this is the basically the complex formulas which are formed by combining the various atomic formulas and the logical connectivities and the quantifiers. Now, what is the semantic of a first order logic, or what is the meaning here? So semantic defines the meaning, and what the meaning we can interpret here based on a domain, a non-empty sets of objects over which the variable range. The interpretation, it assigns the meaning to the constants, functions, and the predicates, specifying which objects the constants refer to, which function the function symbols donate, and which relations the predicate symbol donate, right? Then the truth assignment also determine the truth value of each formula based on the interpretation. So basically we are just in a simple language what output will become or what will be the meaning of a particular statement. So this is the semantic. And now what comes in the under the examples here, how can we use so examples of a knowledge representation in a predicate. Fact simple statements about the object. When we are talking about the simple statements about the object, like object has A has a property P, or object A and B are related by Q. Simply we are talking about the simple property of a particular object. Then whether the rules implications that describe the relationships between an object. So here we are saying that X has a property P, then X also has a property Q. How we are defining here? With the help of a universal quantifier, right? Here we are using the universal quantifiers. Now the uh, existential statement indicates the existence of objects with a certain properties. As here we can say that there exists an X such that Px is true. So here we are P object X is having a property P, right? So here we are simply using that there exists X such that Px is true. Then the universal statements, here we are using the universal quantifier, right? So here we are talking about applied to all the objects in a domain here. So simply for all X, here we are using for all X, either because we are using the or statement here, either Px is true or Qs is not true. Simply we are talking about how to read the predicate statements here. Now what comes under the knowledge base in a predicate logic? Simply a value. When we talk about a constants in a language, in a programming language only, constants are simply a value. So consider a knowledge base representing a simple family relationship here. Constants are John and Mary. Predicates are parent. X is a parent of Y. Male, X is a male, and X is a female here. Here, one we are talking about the property, whether a male or a female or a parent. So X and Y, here we are representing is that X is a parent of Y and X is a male here and X is a female here. We simply say that Y is a female here. We can say that. So what statements we are talking about here? Parent, John and Mary, right? So John is a parent of Mary, or when simply we are saying that John is a male and the Mary is a female. Another thing here in this statement, we can see that what is going on. No one is their own parent. It implies here how we are using a universal quantifiers about X and Y, then using a parent X and Y, then we are using a not statement and we are equaling the X and Y. We are using the assignment operators here, and then with the universal identifier, again we are using this. So no one is their own parent. Definitely it implies that. Then what is the application where we use this predicate logic, or how basically we use the predicate logics in a artificial intelligence. So how can we use? Can anyone explain? So when we are using a predicate logic, why we are using predicate logic is used to represent the knowledge by structuring into the predicates, representing the relationships, and arguments representing the objects. So simply when we are representing a knowledge in a knowledge or when we are creating a knowledge base in an artificial intelligence, we are using a predicate logic to represent the knowledge by structuring the information into predicates, which means the representing the relationships, and their arguments, which means representing the objects. And how it helps the AI system, because in the next we will talk about the applications of a predicate logic. Basically, AI systems, what they do, AI systems capture a complex relationship between the entities, store the rules in a knowledge base, and perform the logical reasoning by making the inferences based on the established facts, or simply we are saying that the established facts or the algos and the relationships through the use of a quantifiers like all or some or the existence. So in that case, we are saying that the predicate logic basically with the help of our quantifiers and the predicates and the objects and representing the logical connectivities with the help of all these components, it allows the AI system to capture the complex relationship between the entities, right? So we can implement this. We can implement a complex relationship between the entities in an AI system. This task can be implemented. And now here we are talking about the application. First application is the expert system. How it is used to represent the expert knowledge in a various domains such as a medicine, finance, engineering, enabling system to reason and make decision based on the logical rules. Simply how logical rules, how it works, it stores the rules within a knowledge base and then perform the various logical logical reasoning by making inferences based on established facts and relationships by the use of various quantifiers, right? So here basically it represents the relationships, right? It represents the quantifiers for generalization. It gives the knowledge base storage, inferences, and the reasonings. That's why expert system and ideal application of a predicate logic. Then the natural language processing. Now, first order logic provide a formal framework for representing the meaning of a natural language synthesis, facilitating semantic analysis and understanding the NLP task here. How now? So with because of a FOL is having the benefits of a flexibility, the structured representations or the relationship between the objects here, which is basically it allows a complex relationship and the detailed information about the entities are present. Flexibility is there and the formal reasoning is there. It provides a well-defined frameworks for the logical operations and the inferences. It works in a natural language processing. Then in a semantic web. So what do you understand by a semantic web? कोई explain कर सकता है? Or what do you understand by a semantic web in terms of a AI? Semantic web is basically a vision for a web that use the linked data. Now again, we are talking about the linked data. When there is a linking there, we are using a predicate or the relationships or the logical connectivities. So it uses the linked data to help the machine to understand and process the information, right? So with the help of which the machine can analyze the data, right? The machine, it is possible for machine to analyze the data, and we can also, after the analyze, the insights of a data will be there, and the information will be there, and the decision can be made. So it is a another advantage here. And how the semantic web work? The semantic web work based on a linked data, right? So it used the linked data. That's why we need the pretty FOL logic here, first order logic here. So first order logic is a foundational to ontologies and the knowledge graphs because of a connectivities and the link on the semantic web, enabling precise and the machine interpretable representation of the knowledge, right? How? Again, by using the linked data, which help the machine to understand and process the information. Another application here, we are talking about the robotics. So predicate logic is employed in our robotic systems to represent the spatial relationships. Now, what do you understand by the spatial relationships or the object properties and the task constraints, right? So what do you understand by the spatial relationships or the object properties and the task constraints, or simply the condition aiding in robot planning, navigation, and manipulation? So here we are using the connectivity again, right? Or simply a connection between an objects, or a connection between objects or and the elements in the physical space. Also spatial relationships, basically we are talking about the arrangement or the connection between the objects or the elements here. And this basically where the something or a particular object is located, that can be represented. So the object properties on the location and the task conditions, it can aid the robot planning, navigation, and the manipulation. Now, another application, we are talking about the database systems. Now, what comes under the database system? Definitely, it helps in a query language system such as a structured query language to enable an expressive query and manipulation of a relational database. As we are talking about the relational databases, again, we are talking about the relationships and the linking between the objects or the entities. So it helps in a database systems also, allowing for the complex data retrieval and the manipulation here. Now, these are the applications. We have discussed about the predicate logic components. We have discussed about its syntax and the semantic meaning. We have discussed its examples and the application also. Now the last, we will discuss the challenges and the limitations of a FOL. So what are the challenges? Challenges, definitely a complexity. When we are combining everything here, expressive limitation is the expressiveness limitations is there because of a complexity. Knowledge acquisition or the gathering of a data is another challenge here. Inference, scalability, again the extensibility is the another challenge here, and handling the incomplete information again. So what comes under the complexity? Complexity representing certain real world domain accurately in FOL can lead to the complex and unwidely formulas here when we are representing everything. So making reasoning and inferences computationally expensive, right? So representing everything about the real world problems or a domain accurately leads to a complexity. So need to handle this. Then the expressive limitations, again, this is linked to the complexity again. FOL has limitation in representing the uncertainty, probabilistic relationships, which are common in many AI applications. We need to express the each relationships in that term that the probabilistic relationships can be represent. So this is a limitation now. Now gathering of a data or gathering of a knowledge or the knowledge acquisition is a uncoding of knowledge into FOL require expertise and the manual efforts. Definitely gathering our information from a large database, making it challenging to scale and maintain a large knowledge bases. Another limitation, we are talking about the inference scalability. Now, reasoning in FOL can be computationally intensive. How? Especially in a large knowledge bases, scalability can be an issue, extensibility can be an issue. requiring efficient inferences algorithm and the optimization technique here. Another challenge we are talking about the handling the incomplete information. So the FOL struggles with representing and reasoning with incomplete or the uncertain information definitely, or simply we can say that when there is a number of formats are present and the number of formats are giving us a uncertain information, or somewhere the information is not complete or the multiple values or the ambiguity is there, which is common in the real world application. Definitely when we are talking about the real world application, the uncertainty can be there and the incomplete of information can be there. Now, what is the limitations here? Limitation is inability to represent the recursive structures. So when we are talking about the recursive structures, we can say that FOL cannot directly represent the recursive structures, limiting its ability to model certain types of relationships and the processes only. So recursive is not possible here. It's a limitation. Then lack of high order reasoning. Again, it's linked to our challenge, the complexity. FOL lacks support for the high order logic, preventing it from representing and reasoning about the properties of predicates or the functions. So here the properties of a predicates or a function is difficult to represent here. Then again, difficulty in representing the context and the dynamics. Now the FOL struggles with representing dynamic or the context dependent knowledge such as temporal relationships or the changes over a time period. Now the dynamic behavior is not possible, or it will be very complex to represent the FOL logic here. Then the limited representation of a non-binary relationships. When there is non-binary relationships, when there is more than two relationships are present, so again there is a there will be a complex representation, so limited representation of the non-binary relationships here. For that, we will use another phrase or the semantic webs here, or the semantic nets. So FOL primarily deals with the binary relations, making it less suitable for representing the complex relationships involving multiple entities here. Now, difficulty in handling the non-monotonic reasoning. Now, what is monotonic reasoning? FOL is not well suited for the monotonic reasoning where new information can lead to retraction or the modification of a previously inferred conclusions. Or simply we are saying that the real world data is dynamic or uncertainty can be there, so it will be difficult for FOL to handle these issues when the data is changing. So FOL remains the fundamental tool in our AI and the knowledge representation, often used in combination with the other formalization and the techniques to address the complex real-world problems here. So simply we have discussed the FOL here completely. Besides of these challenges and the limitations, FOL is again the fundamental tool in our AI for the knowledge representation, and we can combine it with the various other formulas or the formalization and the techniques to address the real world problems that are complex. So what do you understand by the predicate logic? Again, predicate logic is a robust and the expensive knowledge or the language for the knowledge representation capable of encoding the complex relationships and properties of an object in a formal, precise manner. Its use of quantifiers, predicates, and the logical connectivities. These are the main components of a, you need to know what are the main components of a particular logic of a knowledge representation. So it uses the quantifiers, predicates, and the logical connectivities that allow for the detailed specification of a knowledge, making it a fundamental tool in a field such as artificial intelligence, databases, and the formal verification. So this is your predicate logic.